mentioned Gigabay, we're currently laying the foundation for Gigabay here at Starbase as well, and we expect it to be up and running sometime next year. So yeah, there's a whole bunch of Starships on the way, and we're going to need more hands on deck. So come help us build the gateway to Mars. Visit spacex.com/careers to see all of our openings.
Yeah, I've been here for a couple of years now. Nowhere more magical, more inspirational on the planet. If you're a space nerd, you can come be like Amanda and build these things for real. It's pretty insane. It's super exciting. And yeah, come check us out. All right.
Absolutely. It's surreal to be here for sure. Okay, so we are looking like we're about 5 minutes away from launch and heading into terminal count. Range and weather are continuing to look good, and prop load continues on both stages of Starship. We'll close out here in just a minute or so.
Yeah, we're just about done. It looks like, let me grab my numbers real quick. We're not tracking any issues. We are just creeping up to 90% full on the locks on the booster, a little over 93% on ship. Or, sorry, fuel on the booster, and then ship we're just about to close out, so only a couple of minutes to go there. Once we're done, you've got just shy of 11 million pounds of liquid.
All right, everybody, welcome to Today in Space Live. I am your space science podcast host from the East Coast, Alex Giarfanos. SpaceX Starship Flight 10. This is the third attempt at this. Yesterday's everything on the rocket looked good, ground pad looked good, but a storm nearby pushed them out of the launch window, and so they just had a wet dress rehearsal, filling the rocket up, unloading it safely, and now it's ready. But we are now 3 minutes and 45 seconds in. I was fighting my internet to get live yesterday. I fixed that. But today, both computers, both Macs, decided to put me into game mode to figure out how to get things going for this again. We are live. We're doing better than yesterday. I'm happy to be here. Starship is here. So, folks, thank you for joining me. If you're here, let me know in the chat. Say hi. Love to hear from you. If you're new to Starship, let me know. I'm happy to ramble on about Starship, answer any questions that you have. We got 3 minutes to go, people. Flight test number 10. Thank you for being here.
We do have at least one point of no return, though. If the water-cooled flame deflector underneath the launch mount fires off, that happens a little bit after T-minus 10 seconds. That doesn't turn off once it starts going. So we would have to stand down for the day if we do hit a hold or an abort at that point, so we can refill water tanks. At this point, we're not sure if we'd be able to attempt tomorrow because we have fully loaded the vehicle. We have to do a lot of fancy scheduling to get propellant in here as fast as possible. But again, we've got a pretty heroic and amazing team that works all of those logistics, got us into our attempt today after we did a unplanned wet dress yesterday during our attempt. So really exciting to see. But we're coming up on 2 minutes. We've got a green range. We are green for weather. Green has always been my favorite color, only more so now. And we are not tracking any issues with the vehicle today. So we are looking good. 2 minutes to go.
Green.
Yeah, again, not planning on holding at T-minus 40 seconds right now, but in case we do pass that and any issues come up, we can recycle the count. We're pretty lucky that we have this ability. Falcon doesn't have that built in, but being a developmental program, this affords us a lot more flexibility, so super useful to be able to have that. But again, not currently tracking any issues, so hopefully we'll be good to launch today.
All right, coming up on 90 seconds. We've got a pretty good crowd.
The SpaceX team has been working their butts off. I'm exhausted following Starship this week. I can't even imagine what the turnaround times, 24-hour turnarounds for Starship. They've got 3 attempts in now on this week. Like, that's pretty amazing. Look at Hawthorne. Look at Starbase. All these places across the country. People working on the next big technology in space, and the way right now that's available to help the U.S. become a leader again in space. It's the first landing system for NASA's Artemis program that's going back to the moon, setting up the infrastructure to stay. NASA's had a lot of cuts, so having SpaceX do it and not having NASA to pay for it all is pretty special right now. So we're in the balance. 20 seconds left for Starship Flight Test 10.
T-minus 15.
Thank you for joining us for spaceflight history.
T-minus 10. 9.
Oh!
8.
Here we go,
7.
people.
6. 5.
Insane
3.
amounts of
2.
It's
1.
the largest, most powerful rocket ever.
We have liftoff.
Vehicles pitching downrange.
Booster chamber pressure nominal.
Oh my god, those 33 Raptor engines look beautiful!
All right, we're a little over 40 seconds into flight. 33 out of
Booster and
33
ship,
Raptor
avionics
engines.
power and telemetry nominal.
Getting good call outs, healthy systems on the
look at
booster
that.
as it
That's
starts to
wild.
pitch over the Gulf.
Alright, folks, so I'm just saying a lot of words. We're 1 minute in, T plus 1 minute. We're getting incredible views of Starship. We're seeing Starship
Max Q.
enter max Q, the maximum aerodynamic pressure. We just watched it go through that. That was the atmosphere
All right,
pushing
so we are
back
through the
on
period of
Starship,
maximum
folks.
dynamic pressure, max stress.
That's why you
on the
throttle
vehicle
down.
as it continues to fly.
And now that you get through
Our
max
next
Q, you're
major
able to
event is
throttle up
going to
because
be
there's less
hot
atmosphere in
staging,
your
which
way.
is
Then you can go
happening in just
faster
over
again.
90
But
seconds
that
from now.
right there is
To get ready,
critical
the booster will shut down
in
all
making
but
sure
3
that your
of its
rocket
Raptor
is
engines.
tough enough
The clamps
to get to
holding the 2
space.
stages together will release, and the Starship second stage ignites
This is a
its
skyscraper that they're
engines.
flying
The
into
ship then
space.
separates from the super
And
heavy
then
booster
they're
and
gonna
heads to space. At the same time,
land
the
both
3
of
engines
these,
still firing on
if all
super
goes
heavy
well.
will flip the booster around. 10 more engines will ignite for the boost back burn,
Let's dig
putting
in.
the first stage on the path for
for
splashdown
being
in the
with us.
Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
God, these views are beautiful. Good. Nice gentle roll. We're almost at 50 kilometers in altitude. State separation coming up here.
All right, seeing the engine start to throttle down.
Starship to separate from booster.
Miko. Ship ignition.
Let's go, ship. Let's go, ship.
Boost back burn startup.
Yes!
Stage separation.
Yes! That's what I'm talking about. Great
Stage separation confirmed. We've got 6 engines running on ship.
Look at the control they have.
Booster
of
is
that.
doing its boost back burn, continuing now.
It's a skyscraper. They're controlling that thing back to Earth. This is insane.
You heard
you're
them
here,
report
hit me up
ship
in the
chamber
chat.
pressures nominal, so that chamber pressure, just that
almost a
expected
million
thrust
people
level
watching
in those
over
Raptor
next.
engines on the ship.
Insane.
3 vacuum optimized,
Ship
3 sea
avionics,
level,
power and
all
telemetry
looking
nominal.
good.
Look at that. All right, that's looking pretty good, folks.
There's a view into the business end from the ship.
Boost
The
back burn
business
shut down.
end of Starship is looking pretty good. I'm not seeing a lot of strain and extra build up from.
All right, so at this point, we finished our boost back burn, so that was shut down. So that's the first of the 2 burns after a launch that the booster's going to do today. So now it's headed towards the Gulf. it's not going to be quite as an aggressive of a flight down.
Yeah, so they were really pushing the bill on the last Starship Flight 9, and they lost both. So they were able to get data from both. Oh, look at the view of Starship Booster coming back in. That is incredible. But they really pushed the rocket to the limit. And then this is pushing back and saying, what have we learned in this campaign, this version of Booster, moving to another one? What do we know about this version of Booster? How far can we get it through our mission profile? That's beautiful. Wow, that's beautiful.
To the left of the booster. Yeah, we did see one of those middle engines shut down during the ascent. Again, we are resilient to engine out on Super
Starship
Heavy.
Flight,
That's why we're able to get through our ascent.
Man, all I'm saying is,
Starship flying on the expected path.
we're seeing
There's still a chance that engine could be back in the mix for the very start.
we're seeing that SpaceX is really showing us what they've learned about this version of Starship flying. And so far, knock on wood, things are looking good.
All right, so we got a couple of minutes. That landing burn start should be just about 40 seconds away. That's always rad. You can see the boost plume itself in the background as it was coming in.
Look at that. Dude, this is the coolest sci-fi anything.
Right, about 20 seconds to landing burn.
This is sci-fi stuff come to life.
Ship Raptor chamber pressure is nominal.
Come on, booster. Again, a skyscraper. They're controlling this.
All right, here we go.
Landing burn startup.
Firing the landing burn. Let's go. Let's go. I'm liking the control.
Looks like we got 12 of those 13.
Yes.
Down to 3, including one of the middle ring.
Beautiful. Gentle.
Down to 2.
Landing burn
Nice
shutdown.
little hover. And landing burn shutdown. And into the Gulf. Here we come. And the booster has splashed down.
Incredible flight for Booster today.
All right. Already doing better than the last flight test. So far, we're seeing very nominal conditions from the outside for Starship, right? It's not doing a lot of adjustments for attitude control, which was a sign that that methane leak had happened. We're seeing control in both vehicles, the booster and Starship, which is fantastic. That's always a great sign. The soft touchdown and them gathering getting control of the momentum above the ocean that far up they nailed it. With Starship now, we're going to see how things go, because if we can get to the point where they're deploying the Starlink satellites, the fake satellites that they have on board, using the Pez dispenser deployer, then it accomplishes its successfulness in the flight test, right? At that point, just for anything going to space, hey, you got to orbit, you deployed them, big win. The next step for them would be to do the return, the shedding of the speed through the atmosphere using the heat tiles, and then a landing maneuver and a soft touchdown. So that's what we're expecting here for the rest of this live. But so far, we're just about to have second engine cut off. Let's listen in. Thank you for being here. This is incredible stuff.
Let's to go.
Hit us up on the chat if you're here. Say hi.
All right, shut down the vacuum engines.
Here we go. Come on.
Ship engine cut off.
We shut down those center 3. Successful ship
Clean,
engine cut off.
Nazi in.
Seco, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
Ah, beautiful. At least
All right, so ship is in space.
We'll see.
There we
I'm
go.
not 100% sure.
We're seeing the
what
flaps
that
starting
is.
to move into a stowed position. That's why it looks like your camera's moving.
Yeah, we're looking
Yeah,
good,
exciting to
folks.
see
I'm feeling good about
Starship
this.
safely in space, and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking
Look at
good
those
today.
views. Oh my god. Look at the shadow cast by the clouds across the ocean there. That's insane. Wow, that's incredible. Cindy, hello. How are you, Cindy? Thanks for being here. We're looking good on Starship.
Simulators, we've got some payload inside of Starship that we're hoping to deploy into space for the very first time.
Sorry, folks, I didn't
That
realize
deploy
was
is supposed to start at about 18 minutes and 27 seconds into the flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about one satellite a minute, so we'll be spread out over that. It might get a little dark, but after that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit, as we are in a suborbital trajectory, but this is essentially a chance to test out what we need to be able to do a deorbit burn. So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight, and then we get into re-entry. We're looking to get that light show and, more importantly, get that really critical data about the ship's heat shield.
Yeah, exactly. At about T plus 45 minutes, we'll be heading for re-entry. Again, running those experiments with the tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully, we'll also see a splashdown in the Indian Ocean today.
Yeah, we were able to get to a re-entry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this? Before we ever start moving towards, putting ship into a full orbital mission to then do re-entries a little bit later on. So really, really critical to get that data, really looking forward to a controlled re-entry.
Yeah, for sure. As we always say, our main payload is data, but today we also have some actual payload on board, and those simulators that Starship will be deploying, we'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the Starship PEZ dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned.
But look, as far as what we're seeing in there, inside the payload bay, we're looking way better than last test flight. Flight 9 didn't look that great in there. Stuff's looking pretty good. Doesn't seem like there's any major leaks. It looks, I love this. On the far right, there's the 2 different icons, the position on the planet, and then that GD&T, like 3-dimensional space legend for Starship that's in that sphere on the right. That's pretty cool. that's like a whole other side of space, is like just knowing where you are so that you can navigate space, make the right moves to get to exactly where you need to go. It's not easy. It's one of the toughest classes. It's crazy.
We opened the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space.
Folks, thanks for being here. This is Today in Space Live. I am Alex G. Orfanos. We are just about to see the payload bay door open up here. They were just saying that in the background. So these Starlink satellites will deploy one by one, and if they're able to do that, that's a huge step in Starship's like checklist for this 10th flight test. If they're able to get to space and deploy what they need to into space, that's a huge win right there. So let's listen in. And this podcast is, and the stream is currently being streamed over Starlink right now. So that's pretty cool. No affiliation, but just a customer, brand new customer.
And as we mentioned, so we have crossed over
really cool
now at this point into an orbital nighttime. So views from the outside will get pretty dark, but we'll see what we can see. We do this by design. We've been launching these later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few
Cool
seconds
consideration.
until we expect those payload doors to open.
Yeah, it really is amazing how much you need to know and plan for whenever you launch anything to space. Like, at least that's the responsible thing. Alright, here we go. Something's happening with the pressure inside. Assuming that would be to deploy these. Come on. You can do it!
So we are currently in payload deploy prep.
Come on. You got this. Payload bay doors. Fake Starlink
And the
satellites.
door is open.
Pez dispenser activate. Come on. They should be
All
going
right, so
out
the payload
the
door
right
is
side.
open. We should see the first satellite start to deploy at about T plus 18 minutes and 27 seconds. So
Right.
should be only about 30 seconds. So
Here we go. The Pez
one step
dispenser.
closer. Hal listened this time. He cooperated. He opened the payload door for us.
That's huge.
There's a view kind of behind the Pez here looking
Come on.
out into the vacuum of space.
About
Thank you
15
for joining us,
seconds until
folks.
payload
If you're
deploy.
here watching history right now, and a huge step for the rest of the future of the American space program.
Ship has transitioned to payload deploy.
Here we go. Come on. Deploy! Come on. Starlink deploy. Starlink deploy. Come on, Starship. Oh, we got movement! Oh! Oh, we're doing it! We're doing
There
it!
we go.
Yeah! Pest dispenser! Let's go! Nerds freaking out everywhere! It's like that meme.
Pew pew.
Oh my
Been waiting way too long to do that. There we go.
God. Man! They're doing it! Gentle deploy.
There goes another one.
For America? Oh, interesting. They hit the rim so that there's more inertia.
Super exciting moment, as you can hear the energy in both Hawthorne and Starbase. Everyone's super excited for finally getting to
This is
deploy
great.
some of those simulated satellites.
This is really great news, folks.
Pez system moving down. Next row. There we go. As we said, we're going to do about
Starship
one
is
every
doing
minute or
something
so.
in space.
And this is
Deploying
just kind of a
something
dress
into space.
rehearsal for when we're going to do.
So this is huge, folks. This is Starship finally being an orbital vehicle, right? We're looking good for the future here. You definitely could not have gone another flight without serious concern about this getting to space, and we don't have to worry about that right now. Perhaps a Starlink may not go out. Ooh, interesting. It's attempting to reload the deployment. Okay. Very interesting to see cheers from the nerds again. It's amazing how slim that technology has gotten for a satellite. It's such an efficient use of space, which is critical for sending things into space. Before Starship had its payload, even then you'd have to try to be as slim as possible, but very interesting stuff. It's very cool that they got this far, 22 minutes into flight. Watching the final
All
deployment.
right, so we're
of
about
Starlink.
halfway through when we actually start launching the V3 Starlinks on Starship. We're going to be flying about 60 each time, so it'll be about an hour to get through a full
60
stack. But
satellites.
again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable
Man,
gigabit upload download for people.
SpaceX team, we all have very talented people. This is huge. Sorry, folks. Getting used to this live setup thing. I have had quite the week getting set up with live internet. It seems like we've got a good option this time, or we're lucky, whatever the situation is. It's been a lot more consistent. We'll find out later how consistent it actually was, but we've learned a lot this week. The stream almost didn't happen in time for launch, but we've made it. We're here. And that's what matters. It's like the final Starlink batch heading out the payload bay.
All right, looks like we've got one left.
Almost there.
Seconds. The first half and the second half of the match. Got it.
Yeah, there you go. One remaining, so 7 of the 8 have been deployed. One more to go. And then we will have completed our first ever payload deploy operation.
So freaking
Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the Indian Ocean. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
Earth rejoice.
Surveys in Hawthorne.
Success! Starship has finally
There.
deployed something into orbit. Empty payload. And now, the second half, where it will continue in orbit. It will then start to descend and use the heat tiles to shed off the heat of slowing down through the atmosphere, because they are going right now 26,000 kilometers an hour at 190 kilometers and dropping. So this is coming in hot. And so these Starship tiles, again, this is supposed to be a reusable vehicle. They have been testing out this new technology, these new ceramics, the way that they're attaching these tiles so that they can be easily replaceable later. All the technologies that they have had to build in order to get Starship to work is truly fascinating. It really is. You know, as we wait to shift over to the next part of this mission, it's just a really good time to reflect that this was a critical nexus point for the future of the U.S. space program as it exists today. Our entire catalog of Today in Space is documenting up to essentially this point that Starship is a critical piece of infrastructure for the beginning of NASA's Artemis program, which is sending us back to the moon. The first woman, the first Black American to go to the moon, the first Canadian to orbit the moon with Artemis 2. And then we're going to have the humans who are going to land on the moon with Artemis 3 with a Starship. So there is so much of what the current plan is that's counting on Starship. So this is a huge step forward in the technology and the confidence that SpaceX has with it. And they're going to move on to a new version of Starship soon. So very exciting stuff. And again, we're seeing the altitude start to drop. The speed will start to drop as well. And that's when we start using Starship to belly flop its way, boogie board through the atmosphere as it gets itself to slow down before attempting the ocean soft landing. So we're going to hang out here. We can listen into the broadcast. Oh, they're going to go to break. So we are hanging out, folks. We've got a few minutes before we start seeing some new action. Thanks for being here as in space live. Starship Flight 10 broadcast. To jump in the chat, say hi, questions, let us know what you're up to. I'm really just kind of in awe. You know, they made some really good adjustments, SpaceX, to Starship here. So it's going to be really... I'm very excited for this re-entry. So if you're here, thanks for being here. Folks, done a little bit of posting, getting the word out that we're just chilling here, waiting for this next step for re-entry. Still at 169 kilometers, 168 kilometers, 26,000 kilometers an hour. I think we've got some coasting time to go. And if you're new, on that bottom part of the screen there, that's above the time, that's actually a rotating like progress dial. So as new things come up, you'll actually see them ahead of the orbit. That's what that's supposed to represent. So SpaceX has done a tremendous job in the kind of like storytelling of a launch, right? Like even some of the launch broadcasts that you see now from people that aren't SpaceX, maybe some more classic, even some NASA launches, which have gotten a lot better. SpaceX was the best by far for a long time. Like even just having cameras on the rockets as they're going through stuff, like a view like this, really is only enabled in such high quality and as consistent because they have an entire constellation of satellites called Starlink that they just deployed that are keeping the connection with Starship consistent. They have 4 terminals, they said the other day. 4 terminals on Starship, so they could basically access internet and send data, live stream the launch. Because the Starship can just get pick up on the internet as it's flying through the constellation, essentially. Which is just an insane ability for a space company to have. Like, these space companies didn't do all of it. They weren't also the launch provider and also the payload manufacturer And like, there's a lot of stuff that SpaceX has done to disrupt, tech word, the industry, but what they've been able to accomplish technically and from an engineering feat is really, really impressive. And Starship getting to orbit here, right? This sets the groundwork up for test flight 11. I'm not sure what the profile is, but I would guess at some point here we're going to get closer to, I guess you have to test the next version of Starship that they just created. So probably flying a similar flight profile as they're doing today, but probably doing more in orbit. What I really see happening quickly here is them testing the orbital refueling in orbit. Now that's going to require sending up 2 Starship, right? One and then another, which means both of those launch pads could be launching pretty soon. One with a Starship getting ready for launch, and the other a Starship that's ready to launch. That'll be a photo that will probably happen in the next 6 months, I would guess. Because Starship clearly, and the SpaceX team is clearly ramping up operations. You can just see it from all the things that NASA Space Flight and all these people are posting online and streaming constantly from Starbase. Ooh, let's go back. They are talking again.
The relight of a single Raptor engine that should be coming up in just a little under a minute. We're going to be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns. But we've done this once before. This is something we're really going to have to do when we're doing orbital missions. So it's a pretty critical test. We are just a couple seconds away.
Again, I love that. So
Sorry, we're about 20 seconds away. Psych.
Far end,
So we got a little bit more time.
Starship
So we are going to see
compass.
one of those Raptor engines light back
that
up.
is so cool.
We are through the deorbit demo gate, so
The
we should be seeing it
ship-specific
momentarily.
Navigation. I like that. As an aerospace engineer,
Relight
like
demo
that.
startup. And shutdown.
wow.
All right, looks like we confirmed the relight
Yeah.
of one of those center Raptor engines. Second time we've done that. Super exciting.
Nominal
Huge
orbit
congrats
insertion.
to the team on this milestone.
So they just did a little.
Very exciting to
little
That was
see.
a
burst
cool light show.
to get
Yeah.
to the orbit they
I
were
get to
looking
do a
for.
mini version here. So again,
cool.
that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break, and we will see you soon.
T plus 45 minutes. Folks, that means we are here to hang. Put on some vibes. How's your week going so far? What you up to? You got plans for the weekend? And for me, got a Red Sox game over the weekend. Very excited for that. Also busy over in our 3D printing lab. interesting tile placement. We've seen them do that before. I do want to dive deeper into all the intricacy of how they're making this stuff, how they're mounting it, and all those types of things. Now I'm on a new adventure here with my career and things that I haven't had time for in the space world. I will have a little bit more time to start digging in deeper into the technology behind the Starship and what it takes to build a Starship. I think it's an incredible technology. I think the people that are building it are legendary and just nobody knows. There aren't a ton of people that know really what they're working on, and I think they're incredible. Very cool. We've got the orientation of the spacecraft. Angle of attack has changed, so really using the belly of Starship as it's coming in to the atmosphere. We're gonna about an angle of attack about here, which is, you've got Starship. This thing's coming in like this. Belly first. Really trying to shed some speed. And I'm guessing because it's still so high, there's so little atmosphere that, an angle of attack like that is okay. It'll obviously get a lot worse if they start building a plasma on the outside. Yeah, I think I've got to make a bigger Starship model for the podcast to showcase the various parts. Again, this is why I'm excited I get to kind of dive into learning about Starship almost again, because it's been so long since I've really nerded out on all the various aspects of it. So there'll definitely be a design session for AG3D where I'll just go live and we'll start designing a Starship model. Don't have a detailed one. We've got the 3D printing pens, right? These are 3D printed by us, like exchangeable ink cartridges. So if you run out, you can still add more. Those are available at ag3dreplicator.com if you want to help support us and get something really cool. But if you're here and you're hanging out, that's good too. Starship is entering the atmosphere. Again, one of the things that I'm looking for right now is whether the ship has control of itself as it's re-entering. These things that are planned out for very controlled movements. So if it's shaking and moving and spinning and rotating and having to do all these other moves, a lot of flat movements, that to me shows they don't have as much control over the spacecraft. But right now, we've got a lock on the horizon. We're not seeing a lot of rotation, we're seeing controlled movements. We're not seeing a lot of debris. And we're not seeing any signs of leaking right now. These are all great signs, especially as the stress in the vehicle starts to increase. It's going through the atmosphere. Temperature of one side versus the other is starting to get even more grossly out of sorts, right? It's expanding, right? This thing is made of stainless steel, and there's a bunch of other things. Like, as that inside is dealing with stuff, it is heating up. Tiles are taking the brunt of it. But, I mean, you can see. But they are looking controlled. That's my point here. They're real close. They're doing good.
We're about to start barreling through the Earth's atmosphere and
Speed
head
of
for a
sound.
splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of kind of the hardest engineering challenges still out there for us. And so this is the time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system end up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the
Wow, look at
spacecraft flying
the
through the
heat tiles
Earth's
are different.
atmosphere
We're
at
seeing the
hypersonic
wrapping of
speeds or more than 5 times the
ceramic
speed of
tiles
sound.
around.
Yeah, throughout history, a lot of
Fins.
times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers
Business
down
end
on
of
the
the
ground.
spacecraft's looking good.
Starship's big size kind of gives us awake, but what really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see.
did
So
not
we
look
started, we just saw some of the aft skirt just take a hit.
Plasma belt. That's
So
really
we've got some visible damage on the aft skirt. We're continue to re-enter though.
Like we were talking
And again,
about,
we
spacecraft
are
is heating
intentionally
up to
stressing the ship
extreme
as
temperatures.
we go through this. So it is not guaranteed to be a smooth ride down to the Indian
Now,
Ocean.
well, that's not
We've
great. That could
removed
have
a
been
bunch of
fuel in
tiles,
a line,
kind
a
of
minor
critical
leak that
places
just finally
across
caught
the
fire
vehicle.
because the
So
atmosphere
seeing
is
stuff
so
like
hot.
that
It's
is
plasma
still
right now.
valuable to us. We are trying to kind of push this vehicle to the limits
But
to learn what its limits
the
are. as
control
we
of
design
Starship
our
is still
next
there. It's
version
still
of
managing
Starship.
to
So 47 minutes,
use the
45
flaps.
seconds into the
It's
flight.
still in a good
Excitement
orientation so
ticking
that
up a
the
little
heat
bit on
tiles are
re-entry
taking
already,
the brunt of the
but the
atmosphere.
light show is continuing. This re-entry is going to take about
Wow,
20
look at
minutes or
that.
so until our planned splash.
Wow, look at that plasma view. That's insane. Oh, we're looking at it just ablate. Wow. Guys, I would have paid so much money for a textbook that had pictures like this back in college. And I already spent a ton of money on books in college. To see this live streamed is just such a gift. We did not have this 10 years ago. Holy. So if you look in the bottom right of the screen over there, we definitely have some damage. We have heat tiles just slowly bleeding away from the plasma buildup.
Heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this
These are
camera for us. It
incredible
was
views, folks.
a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down.
And it's still connected to Starlink, like full streaming
The
capabilities.
hit
right
we
now.
saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, you know, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn. But for now, we are obviously continuing with this reentry. We are committed. Indian Ocean, here we come. 50 minutes
75
since launch.
kilometers.
We're going to see
Wow, that's a lot
those
of
colors start to build up a little bit. We are at the point where we're in dense enough atmosphere that the flaps have control.
Wow.
So about 74 kilometers in
Now they're
altitude.
experiencing some.
You were starting to see some sunlight, so we intentionally time these launches right now so we have
was like
daylight. The
plasma
sun should
turbines.
actually
That
come
was-
up over the
that was
horizon on
crazy.
Starship in about 3 minutes. So as we get a little bit further into this reentry, that inky black below you is going to start to look
Yeah, it
like
is
clouds and
crazy.
hopefully a bright blue ocean as
To
we make
think
our way
that-
down onto the other side of the planet.
Like, I would be concerned for aluminum in this scenario.
We've got these cameras. These cameras are really cool. We added these
where I'm
several
glad
flights
stainless
ago,
steel is
looking
being used.
directly at
Although,
the
like,
flaps
Look at
as
that
not just the heat
far
shield,
right
but these
side.
flaps, how they're able to
heat is
control the
so-
vehicle, withstand
Sorry, folks, I'm talking
that.
over you. The heat is so insane that it's just boring itself through the place with the most resistance, right? Which is the corner. Yeah, this Starship is getting roasted. Man. It's wild seeing just all the burn off from the heat of this thing going through the atmosphere. It's so massive.
Attempt to flip and a landing burn. We do have.
Folks, if you're still with us, we're getting close to the exciting end of this. We should see a belly flop flip maneuver if it's able to get that far over the Indian Ocean. It's getting roasted with the atmosphere here, but so far the tiles have held up, so we're getting close. Thanks for joining us. Wow, look at that. That's insane.
All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
Crazy.
Yeah, and after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic,
Over the Earth.
we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of the ship itself, specifically those aft flaps, so the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But
Yeah, and look, that's a really important thing to touch on here. Like a good test is one that you're pushing the limits of what you're comfortable with, right? Especially if you're trying to make rapid development like they're trying to do with Starship. So, you're going to need to create tests that are pushing it. Like the last test, they pushed their technology farther than it could go. But what they did is they used that knowledge. And they've gotten to this point where now they're back in the game, right? They launched Starship. They separated the Super Heavy booster. They soft landed the Super Heavy booster, showed control of it. Starship went to space, deployed the Starlink satellites, and now going through the atmosphere, still mostly intact. It's definitely dealt with more extreme conditions, and we're gonna see how much it can handle, because you want to be able to say you flew this in worse conditions than you would ever put a human being through while they're on board. So even just for the ultimate goal of this ship, which is to send not just a few people, but up to 100 people to space to land on the moon or Mars or wherever, this thing needs to be reliable. So there may be explosions, but this is to make sure that we know this thing well enough to reliably and robustly send human beings on this. So that's another reason for this testing that's really important to know.
Maintain control, maintain attitude of the vehicle as we're coming down.
You know, another thing that I like to think of when you see these views of like Starship going through the atmosphere and it's got all this plasma buildup, you know, those particles of air are basically sitting still. And the Starship is just going right through it. So, like, it's gonna try to get out of the way, but those particles that are there, the plasma buildup, is from the particles that can't get out of the way. And so you see this insane amount of friction and heat built up because we're just pushing space, right? It's a really cool thing to see live in person. Still blows my mind that we can get these kind of views. And then you get to see, like, yeah, that's why the corner of the flap is gonna get the most amount of heat, and then the most amount of friction, the most amount of heat and damage, is because that's where the particles can't get out of the way the easiest. So I don't know. That's a nice way to think about what's happening, the physics here, because it's insane at scale. It's a skyscraper falling through the sky. Wild.
Minutes away until we hear that we're transonic.
So another 5 minutes of shedding speed. Yeah, but that idea with the particles, like, that's fluid dynamics. That's a big part of, if you're going to go to school for this in any way, you know, knowing fluid dynamics is really important. How things move, how fluids move, because you're going to need that for the rocket engines to send the fuel. You're going to need that.
Still a little bit toasty on the aft skirt
of
the vehicle as we continue coming in.
It's going to go into space and there's nothing up there, but you've got to go through the atmosphere.
Again, we are intentionally stressing the flaps so we can learn all we can.
So you need a pretty robust vehicle to do that.
All right, so now we're
luckily
already
SpaceX
well
chooses
past peak heating.
on the regular, which is incredible. But damn, that flap was roasted.
Just about 48, 49, counting down to 48 kilometers in altitude.
Chart.
Expecting that transonic to come, so transitioning between the speed of sound and subsonics lower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again, this is meant to test the extremes for the vehicle.
change in view. The orientation of the spacecraft from doing that. Whoa. Oh, this is crazy.
All right.
Wow.
See those flaps swinging out? Again, we're putting ship through the ringer on this flight
they're
end.
going like 10,000 kilometers an hour, and they're just playing with the flaps. That's crazy. Wow.
It's like we're still maintaining control.
Wow. That's insane. Well, the stainless steel metal on the spacecraft is now getting quenched
All
by
right,
the air.
flaps earning their paycheck today, getting through kind of that max stressing.
Usually you need a special process for that. But you just get it for free.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship, one of the changes we made after Flight 6 was to change the tile line a little bit. So we had kind of scaled back the number of tiles significantly, as when we go to catch these ships, you don't want to, I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so to kind of address that, we smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spot, a little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost, they almost look like gouges on that. So it looks like that's been pretty successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watch some of the high altitude tests or suborbital campaigns, we were able to test that. It was a pretty fundamental, like.
It's wild to think that there's a possibility that Starship gets so reliable that people fly this around the planet to get anywhere on the planet in 30 minutes. I don't know if I'd ever fly that thing like that, Earth to Earth, but it's crazy to think that just like the Concorde, like it's possible. People would probably pay for that. People are in a rush all the time. And if you can skip the airport experience, wild stuff.
All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic. We are starting to chill the engines for a landing burn attempt.
Engine chill.
Landing flip supposed to start in a little over 2 minutes. Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
There we go.
Folks. Belly flopping.
Farewell,
Starship.
space.
Flaps burned. Roasted. Still functional. Dropping into the clouds.
All right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer.
So
Dipping the nose down a little bit.
Free diving Starship. Now we're looking for those flaps to hold as they try and do this.
2 of our engines chilled in, waiting on 1 more. So again,
Starship
we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
An hour, 5 minutes, and
Just about 1
14
minute now from
seconds
that
into the
landing
mission.
flip and landing burn start.
We're at 5.3 kilometers in altitude. They've dropped their speed all the way down to 440 kilometers an hour. About to fall through the cloud line.
Structurally, we're looking good.
Agreed,
Got good
they are
pressures in
looking
our
good.
nose cone for everything. Just about 30 seconds. So again, we're going to look for the flip. So Starship's doing its belly
incredibly
flop right
far.
now. We're going to do the flip. Swing
Finale
out.
is right
Let's
around
punch
the
through some
corner.
clouds first.
Here we go. Oh, that's such a crazy view.
Here we go.
Oh, here we go.
Starship landing burn startup.
Landing bird startup. Belly flop flip. Here we
Seeing
go.
3 engines.
Engines relit.
There's our flip.
Oh! Yeah, buoy cam.
There's
Woo!
a buoy.
Oh my God.
They did it!
There's a splashdown.
It blew up, but they did it!
Hey.
They did it. Starship launched, went to orbit, deployed. Soft
Oh,
touchdown.
man. Yeah. Farewell, Ship 37.
Ship
Thank you,
37.
buoy cam. Landing flip,
R.I.P.
landing burn. Splash out of the Indian Ocean. There we go. Whew. All right. That was pretty awesome.
Incredible
This is
flight
cool, right?
today for both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another exciting Starship flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was, it was great being with you today. Back to you guys.
That was absolutely incredible. Huge congrats to all the teams here.
Wow, folks. Starship successfully getting this launch of Flight 10 off the ground, and into orbit. Again, we can't say enough that this is a huge moment for the SpaceX program, for Starship, right? To be able to have this ship that can send up to 100 people to any place in the solar system. You'd be able to land it. You would land it near some place where you can make the fuel, right? It's methane and oxygen. You can find that. You can make yourself fuel and come back. Ideally, long term, you would have fueling stations and you would just do that. But we're nowhere near that. We don't have a spacecraft that people can just readily fly around the solar system. This would be the first one that would really push our ability to send humans around the solar system to a whole other level. It would change how working and living in space on a regular basis would happen. And what they accomplished today is really important for many reasons. Number one, that means the Starship program is at least back on track to making progress and pushing Starship again. They have a new Starship booster and a new ship and booster design that they'll be testing soon. They were able to deploy something in space for the very first time, which is a huge deal for launching anything in space. And when you're testing a launch system, that is a huge first milestone. So a huge congratulations to the SpaceX team, to the Starship team, to the thousands of people that are working day in, day out to get Starship progressed to the point where they will then ask for more work because they'll be launching multiple of these potentially a day someday soon. There's a lot of work that needs to happen, and the estimates of how fast they would get there are already, not as fast as they would like it, but that's reality, and they're still making progress at breakneck speeds. So this is a huge day. And then finally, the other big aspect of this is that Starship is going to be used for NASA's current plan that they've been working on and adding funding to for the last 8 years. Starship is the first landing system for humans going back to the moon on Artemis 3. It'll also be the lander for 4. And then Blue Origin's Blue Moon lander will take over. So for NASA, for the future of the American human spaceflight program, it was a huge day as well, because Starship is a critical piece of that infrastructure. So a great day. Can't complain. It did take 3 attempts to get there, but essentially a flawless mission. And they're back on top of things. And Flight 11 is probably going to come really fast because there was no pad damage, and they've been working on the other ship and booster. So we may see one very soon, but all I have to say is thank you for joining us for Today in Space Live for SpaceX Starship Flight 10. A very successful day. We finally got our live situation set up, and we're just happy that you were able to join us today for a little bit of space history. I am your Space Science Podcast host from the East Coast, Alex G. Orfanos, wishing you a good rest of your week. Spread love and spread science. Stay curious, and we'll see you on the next episode